My name is Scott Miller. The name of this video site is Anagalactic because it needs to have a name, and I chose that name. Over here, to our left, you will see the moon. The reason I have that here is, first of all, to let you know you're at an astronomy site, and second of all, there are two geometric features here that I will be talking about in this lecture. Just so you know where you're at in this lecture series, I have produced 300 lectures in the past 9 months. Well, let's say 10 months. That's quite a few lectures. I never expect that you're going to listen to them, but I uploaded them to YouTube for a reason. This has been an astronomy site since June 2nd, and I have been on a rather interesting journey for the past year, which is why I started uploading. So to get into this, I'd like you to see this, which basically I covered in the last lecture, item by item, maybe a couple of minutes devoted to each one of these topics. You can see that this is rather a huge topic list, in the sense these are very large topics. The realm of the cumuli is simply to give it a title, somewhat like my name here, Anagalactic. It's just a name. But cumuli, you may wonder why I use that word. In fact, you may wonder why I use the word anagalactic. I have spoken about these things in the past, but we are starting a new lecture series, so if you're tuning in for the first time, this is good timing. But I do like to keep my lectures self-contained, so you never have to reference anything else. That involves, of course, a balance. You see, I've highlighted one of these topics, spheric geometry. Spheric geometry is essentially, you could say it's a theoretical geometry, because I don't know if you've ever heard of spherical or spheric geometry, but I did a exhaustive search throughout history, and I'm very good at research, and I did not find spherical geometry. And if you do find either a website or a book or someone who knows spherical geometry, I would greatly appreciate a comment. And when I say greatly appreciate, I do not ask for money, but I might be willing to pay for information. Because 1 year ago I discovered what appears to be a new geometry, which, I'm sorry, but I have to be honest, I myself would not believe this if someone else said so. That is, that they discovered a new geometry. So that is going to be my subject for the next 3 months. I've been saying since the equinox that I'll be broadcasting on spherical geometry until the solstice at least. I've had to organize in a certain sense, because 300 lectures, that's quite a bit. And I've had a good deal of fun, and this has grown as I've progressed. But the reason I began uploading to YouTube is not because I am a scientist, certainly not in the accredited or industrial sense. I am a scientist in the broadest sense, as so are you. But I don't really represent anything. I am an outlier, a loner, but I'm not a troll. I am not trying to prove anything, and I don't want money. So, that's a brief introduction to what I will be talking about and what I have been talking about. How about right now? I'd like you to take a look at this photograph here of the moon. And we're going to go through a series of photographs. I want to show you rather quickly what you can expect. We're going to talk about this, that's Saturn. Then we're going to talk about that, that's a galaxy. These are interacting galaxies. These are exploding objects. at galaxy scale called active galactic nuclei, which is a very misleading name. I'm an expert on this subject, not in the industrial sense. There are probably thousands of scientists and professors who would consider me to be quite naive, but in the realm of science, we're all involved, and as long as we're not nuisances to those who get paid to do what they do, we are certainly not excluded. Science is for everybody. This is a very specific kind of structure in the sky. That is a galaxy-scaled object in the middle. Although it's not a full-fledged galaxy, we'll be talking about that briefly. This is the center. It's the Milky Way with the dust band. It's a very good photograph, as you can see, towards Sagittarius. Astronomers know that as the teapot. There's a reason for that, but if you don't know, I'll leave a note on why it's... Well, I might as well tell you. Sagittarius is shaped like a teapot, but it's very interesting. I've seen this many times through telescopes. I never get tired of it. It looks like there's steam coming out of the teapot, and that's the Milky Way band. Of course, that's called a line of sight illusion. It's not steam coming out of a teapot. But it is certainly memorable to see. I mean, it really is something else. But Sagittarius, you can see the teapot. I don't have a pointer, but if you were to look closely at this photograph, you would see there are pink stars in the middle of that dust band that are the teapot. What this is meant to show this is an introduction to, you may see the caption down here, Sagittarius A star. Well, what in the world is that? If you already know, forgive me, but I have to assume that I'm talking to all age groups, because that is whom I address, all age groups. Everything you hear on my channel can be understood by anybody at least down to high school level. And I claim, not without reason, but this would require proof, I can teach all the material that I teach down to about the 4th or 5th grade. That's pushing it, but I need to be bold because I do need to have a certain amount of input at this point due to what I'll be talking about tonight. Has to do with this new geometry that I apparently discovered. After we talk about Sagittarius A star, which is, as you can see from the caption, our own black hole. You may have heard about the black hole. I'll be teaching you about the black hole in a way that I can only assume nobody else on Earth is willing to talk about. And you may think, well, I'm in for a crank ride. I strongly suggest that you listen, because the black hole is actually an amazing phenomenon. It's an amazing phenomenon. But there is a lot of hype, and I'm not alone in saying this, even from within the industry. There is a lot of misinformation. There's reasons for that, which have to do with, you would have to know why people are doing what they're doing when they say things that they cannot support. But don't forget that the space industry is driven by about $1 trillion every year from the government. There is no higher outlay of money from the government of the United States, certainly, than for space exploration, for obvious reasons. But I won't go into that right now. After we're done talking about our own black hole and several other black holes in general, just so you know what they are, then we're going to talk about this man. Although not about John Horton Conway himself. He's a Nobel Prize winner, but unfortunately he died. And the Nobel Prize is not given out after you're dead. It's unfortunate, and that's how Henrietta Leavitt missed out, almost certainly. Stockholm nominated her for what would have been the only prize in astronomy ever given by Stockholm. For the Nobel Prize in Physics, they were considering giving it to Henrietta Leavitt. But in those days, they didn't have cell phones. And by the time Stockholm found out, well, they had to reach her, which meant that they pretty much had to go to her. But they found that she wasn't there, and they talked with her boss, Shapley, Howard Shapley, who, unfortunately for him, earned himself a blot that will live in infamy. When he was told we'd like to nominate Henrietta for the Nobel Prize, and Shapley told them, well, she died of cancer within the past year, but you should give it to me instead. That is, well, I'll leave it to you to... So there's our man, John Horton Conway. He's one of my teachers. I name about 4 or 5 men who influenced my geometry, which is not just a geometry. John Horton Conway was not a geometer because nobody is a geometer in industrial science. They don't need geometry, they need calculus. That's not talking out of class. They all admit it and they all know it. They don't want geometry. Now, this does not impugn Conway in any way, but the reason I make that distinction between geometry and numbers is John proved for the first time in mathematical history the relationship between the geometric object called the line and the number system, all the numbers, any numbers, every kind of number. Here is his tree. You can see this in, there's various diagrams of this. Down here we're going to have an expansion on this, which is all the kinds of numbers in what's called a Venn diagram. So you know what a number is, because now we know in science. Before John was born and made his discovery, nobody knew what a number was. Of course, there was a working definition of the number, but which kind of number were you talking about? We're taught the real numbers. Those are unreal, and I'll show you why. The surreal numbers are what he discovered, but this man, whose name is Donald Knuth of Stanford University, who's still kicking, still going, very famous, certainly in the computer industry, but he got hold of John's book describing his new number definition, which really nobody had noticed. Some had, but not a lot. And it's a little bit uncertain why, at least to me, why it took so long before the science community, particularly the mathematicians, figured out what John discovered. But when Donald Knuth got hold of his book, he named the numbers. He's the one who called them the surreal numbers, got back with John about it. John loved it, so do I hope you do too. Surreal calls to mind, for those of you art lovers out there, Salvador Dali, certainly one of the greatest artists who've ever lived, was a surreal artist. And so it's an interesting word. It's a play on the word real, which is about the stupidest name for a number system ever devised. Mathematicians are known for stupid names for things. Real numbers. It's quite ironic. I'm kind of glad they were named real numbers. We'll be talking about that briefly. Here is the expanded diagram. At the center is 0. And that's what I talk about a lot, is that number. On both sides are what are called the natural numbers, and there are the negative ones and the positive ones, labeled n here, right bracketing either side of 0. I'll be talking about that because that's in John's graph of what the numbers actually are. The z, for some reason, stands for integer numbers, and then comes q, which stands for the rational numbers. Those are the only numbers that the universe uses. The universe only uses rational numbers. Right outside, this is a Venn diagram, so these are supersets going out towards the right, ending at NO, which is, it's actually has some kind of meaning, but that's the surreal numbers on the outside. And that is the definition of a linear number. A linear number. Everything in this list is a linear number system, with 0 at the center of all of them. Of any of them have 0. Except you'll notice the natural numbers don't. It's only the natural numbers that are used in rational numbers as components of a two-component number. A rational number is a two-component number. Now that's not strictly true, but I'll show you why that's the right way to say it. Going out, you have the real algebraic numbers and then the real numbers. These are the ones we're taught in school because they're supposed to be the closest thing to a continuum. The number line is supposed to be a continuum. It's anything but that. I'll be talking about that as well. It is almost completely irrational. And John proved that. And everyone knows that it's true now. Nobody has ever argued with him. It's very hard to argue with John Conway. Of course, he's at the top, although he is dead now. He died of the COVID virus 3 years ago. Let's not go into any more extraneous detail. It's very easy to get caught up in any one of these topics, but I'd like to breeze through so that you have an overview of what's coming up. This is an upside-down tree of the number system of John Conway. That is not as good as, there's another one, this one. This is a upside-down tree. Well, actually, this is a normal tree because it grows up. But it really depends on what you mean, because a tree has roots. And so this one here that I'm highlighting, you could think of that as growing up. But the other one that we showed, this one, you can think of as growing down. These are the same diagrams, so don't let that confuse you. I prefer the downward growing one, although this one is better. Wouldn't you know it? Let me show you that a little. I can't center that, but I will be explaining this, and don't worry. So we're going to go past the numbers, just so you know what they are, and then we're going to talk about the definition of a number, especially the numbers 0, 1, and 2, and the fractions. And this is a very famous YouTube presenter. I have his face on here, because he represents the two faces of popular science. This fellow is extremely good. And I'm actually not sure what his name is, although I did see it once. But it's called PBS. It's not Public Broadcasting Station. It's his name, PBS. And this is PBS SpaceTime is what this is called. He's a very good presenter. This is a 26-minute video that we're not going to watch, but I turned on captions and froze it here. I'm going to read what he's saying at this time in this video. This was produced 1 month ago. This man has close to 1 million views just for this video. And this is entitled, "What if Space and Time Are Not Real?" And this is where he's beginning. It's only 14 seconds in. I'll just read this. "This may require us to do away with the most intuitive and seemingly fundamental concepts of all time." Space. He means space and time. It doesn't show everything there. A little further on, and the reason why I wanted you to see that is because, isn't that a little bit odd? That is very common now, and I want to just alert you to what's going on in science right now at the Fermi edge, not the cutting edge, the Fermi edge, where things are still happening as they always are in science. We're trying to push the boundaries at all times. We're having a major problem making progress in astrophysics. And that means that we astronomers are hugely frustrated with astrophysics right now. But there's a reason for that you need to know. Just so you know why people are saying the darndest things. There have been quite a few, I'll just say, discussions started that have been raging for decades about reality. I have a 3-video presentation on the 2022 Nobel Prize in Physics, which was awarded for a philosophical point of view. As far as I know, that's the first time in the history of the Nobel Prize in Physics where the prize was awarded. This was less than 6 months ago. The prize was awarded for a point of view in philosophy having to do with reality. So everything is being questioned right now. There is a very, very good reason for that. But it's led to some almost comical, and some people think tragic, developments. I have shared both sides, but I prefer comical. This should be fun. Nobody's being threatened. Nobody is necessarily lying, although that actually, you hear that maybe there's like a conspiracy to keep us from knowing things. If so, it's one hell of a damn good conspiracy, because they don't know. That is, the experts, the professionals, the Nobel Prize laureates themselves cannot solve. There is a list of paradoxes now in astrophysics, but that's only half the list. You know what the other half of the list is? It's the quantum mechanical paradoxes. And it depends on how you count them, but I read Kumar's book, and if you want to know everything that there is worth knowing about quantum mechanics, you only need to read one book. It's by a man named Kumar, K-U-M-A-R. If you look hard, you'll find that book online for free. And I will be posting at my site links to books which are more precious than gold right now. But for necessary reasons, I'll just put it that way, there's quite a bit of intrigue afoot right now. And even I'll put it that way to my own credit, even I have been tempted to say that information is being withheld from you. It's not conscious, though. So I don't talk that way anymore. It's just, we're going to treat it lightheartedly, but you might not think it's so lighthearted after you hear some of the things that I have been sharing in these videos. They're in Wikipedia. I mean, I don't make up anything. Everything that I say is documented, but it's just stuff you don't hear. It's the other side of astrophysics and the other side of quantum mechanics. Quantum mechanics is a different animal because we've reached an inner limit where it seems that our numbers are breaking. They are. I can say that because I can prove it. But it's a different problem in outer space, in astronomy, astrophysics, what we call the universe. What do you know about the universe? I can tell you this. Whatever science and we as science know about the universe, we've only known it for less than 100 years. I think that's very important to bear in mind. That's offset in the common mind, which I share. I believe I speak for all of us when I say we automatically compensate for that with the realization that our people, our scientists, have way more access to knowledge. In other words, even though we've gotten a huge amount of new knowledge that we simply did not know, until we saw into the galaxies and past them. We had never seen what could be proved to be a galaxy until 1 century ago exactly. It's been exactly a century now. There's always a little bit of a fudge factor in science because there were men for upward about 50 years prior to Hubble's discovery in the 1920s of the first conclusive proof that Andromeda is indeed not part of our star system. That was simply unknown, but with a footnote. All the way back into the 1850s, that actually had been known, but not on as strong of proof. Its spectroscopy, which was available in the 1850s, it could not be used by astronomers until there was photography. And photography had just been invented. So the first men, and women, of course, whenever I say men, I mean men and women, of course, had taken a spectrogram of Andromeda in order to see what kind of light it was, because if it's stellar light, you can tell with a spectrogram that it's stellar. They wanted to know because it was controversial. Nobody knew if Andromeda was made of stars or not. They found out. The most accurate thing you would say is they found out that it's stellar light. It looks just like starlight. But they couldn't see any individual stars, so that was not conclusive. But after World War I, the Wilson telescope came online, and the way astronomers say that is that the telescope saw its first light. This was by far the most powerful telescope ever built. There really weren't any big telescopes before that, except, of course, that would be quite unfair to leave it at that. There was a telescope in Ireland, a 72-inch diameter, I believe, which is the Hubble not the Hubble telescope, but the telescope that Hubble used was a 100-inch telescope, which, you know, the surface area that captures the light goes up as the square of the radius. So it's not just a little bit bigger, it's a lot bigger in the sense of capturing more light, which is the objective. But the Leviathan was in all places in Ireland, and a man named Parsons, who is known by his title, Lord Bross, he was very, very good at using this telescope to make discoveries about stars, but he could not resolve stars in Andromeda or in what were called the nebulae. So that's a little brief sketch of what's happened to produce this kind of man who is saying, what if space and time are not real? That is a very strange topic, but it's actually typical. There have been some, it's okay to say this now, because we all in science know about what's happened over the past 70 to 100 years, but there have been some harebrained ideas. Harebrained ideas. You may have heard of the many worlds theorem, sometimes called the multiverse. Those are actually considered to be two different things. Many worlds or multiverse. Well, whatever. And black holes are considered to turn space inside out and time inside out. The Big Bang is supposed to have come just out of nothing. Just unbelievable thing. And my favorite, the universe is expanding. This is going the way of something I saw in my youth, being raised right here in America. We were all trained, and we had to say yes to this, that we're from monkeys. That natural selection is true, that Darwin got it right, because there's no other theory. Yeah. So the same thing is happening now. You're required to know that the universe is expanding. It's indistinguishable from propaganda. And here we go. Let's keep moving. This is Roger. If you want to pronounce it the Croatian way, it's Ruđer Josef Bošković. And tonight I met with a Croatian man. He's a merchant, so I shop at his store. And he is from Croatia. And I asked him again, it's Ruđer. And he said, oh, I'm going to start calling you Ruđer Bošković. So I got to hear his name in his native language. He was a Croatian Jesuit priest who came up with the most amazing theory in the highest sense, and his work is coming back online. He was a classical mechanist who studied calculus right after Newton and Leibniz invented it. And Roger, I argue, knew calculus better than either of them. And he didn't really need it for what he discovered. And that's where I come in, but not right now. This is one of Roger's curves, and this is by far his most famous curve. You might say, well, what in the world is that, and why would you show that to us? Because we don't know any... This is what scares people. Let me inform you what this actually is. So I'm just highlighting this to show you that I wish that I could point, but right above the blue area, you will see a series of curves. I want you to look at the top of each curve, and you'll notice there are 3 obvious ones, about half the height of the overall graph. The first thing you need to know is, what does this graph represent? This graph represents the relationship between 2 particles. Particles. Yes. And you notice that there is this curve. What does that mean? It means that when the curve is above the median line, the horizontal line, that there is either an attractive force or a repelling force. And it depends on which 2 particles. I've added that information. This is actually considered to be at the innermost curve where it shoots up. You see it shoots up. And then you see there is a mirror image on the other side of the vertical line labeled A and B. You can forget about that. That's just the linear reflection of a linearization of a force curve. This is the internationally famous, top-notch famous now, Bošković force curve for particles. The range is in femtometers, the smallest useful measuring unit in physical space known to science. And these curves are approximately 1 femtometer apart. And the inner one, where it shoots up off the graph vertically, the median line, that is the vertical line, that's the center of a particle. And the reason why it's on the whole line is because this curved line shows the approach. You can think of it that way. It's the approach of one particle directly toward the other particle. That line, the horizontal line, is the path of the particle. So it's very important to realize that the curves in this line are not changes in direction. It's nothing to do with direction. Only the linear part is direction. The curved part is a relationship between distance and force. When the curve is above the line, it's attractive force. When it's below the horizontal line, it's repelling force. And if you're very I strongly recommend that you not only study this curve, but you may want to put pictures of it around your house so that you can see it a lot. And I don't expect you to do that, but you would not regret, if you're into geometry and you're into understanding science, this is the most important diagram you will ever see in your life. And it's just now being realized. And I'm one of those who has realized early, this is going to change everything. And I'll tell you why in a moment. And then finally, I want to show you part of Rogers' curve. There it is. That is the innermost curve of this. If you can read the letters, I wish I had a pointer. I am so sorry that I don't have a pointer. But you can see the blue area that I'm highlighting here. Right above that blue is an F. And then over here, where I highlighted in blue again, that A that you see on the horizontal line, where the vertical line goes up, A, normally that would be labeled 0 because it's 0 distance on the horizontal, and it's 0 force. But you could see that this particle could arrive at the other particle anywhere on this line. Because the whole line is actually the center. It is the particle. Or you could say the center of the particle. Well, which is it? That has been the topic of debate forever. Is A, that is the particle, is that just a 0? Or does it have a radius? This diagram gives the answer for the first time. It gives the answer as to what is a particle. In terms of an ancient controversy, which Newton engaged in and Leibniz engaged in, which has to do with impenetrability. The most important topic in classical physics. It has not gone away. It is now called quantum mechanics. This diagram shows the orbital shell system of an atom 150 years before the atom was discovered. This is not Rogers' curve, because he did not draw this. A computer drew this for Wikipedia. And let me show you the name of this article. You probably saw it, but let's make sure. Nuclear force in Wikipedia, the free encyclopedia. Nuclear force, which is what? The nucleon-nucleon interaction. That means protons. And the reason they have to say nucleon-nucleon is because if you say proton, you're wrong. Not because you're wrong, protons are nucleons, but I think you know that there's another nucleon called a neutron. You know what the difference is between the proton and the neutron? Almost nothing. And we'll go into that. That's actually one particle that changes state on a quark harmonic. But that's called there are two uses of the strong force. And you'll see here, Wikipedia recognizes that the strong force is ambiguous. There are two strong forces. It's extremely easy to get them confused because the physicists got them confused. Because they use stupid words. Strong, that's like black. That's like bang. That's Big Bang, black hole, strong force. It's because they're confused. They really are. And they know it now. These are subatomic particle physicists and astrophysicists. They're reduced to simpering, quivering, afraid little tiny boys. They're scared because they don't understand what they're looking at anymore. To believe in the Big Bang is to be psychotic. To believe that the universe is expanding is psychotic. To believe that humans are descended from monkeys was psychotic, but obviously we can live with that for a long time. A scientist can't. So that's what we're going to be covering, but we begin at the moon. Why? Because it's a sphere, and it's the closest sphere to us. Now you might object, you might say, well, the Earth is a sphere. Oh, God bless you, my friend. Yes, it is. Yes, the Earth is a sphere. And it takes a long time to realize that. You know how I know? I think you know, because you learned in school. Mankind took a long time to learn, to be able to prove scientifically that the Earth is spherical. But the Greeks accomplished it. A man named Hipparchus, Aristarchus was another big name, but then everyone forgot that the Earth was spherical. And in the Middle Ages, having lost this information, which was only recently recovered from the Greeks, the Arabs knew it, but the Europeans didn't. That the Greeks had figured out that the Earth is a sphere. Well, Christopher Columbus sailed from pre-Enlightenment Europe just having found out that the Earth is spherical. But he didn't make it. He didn't make it across the Pacific because there was an unknown continent in his way. That's only 500 years ago. Only 500 years ago, no one in Europe or Asia knew about the Americas. What about outer space? Well, we knew nothing of outer space. Not quite. There's always... That's too extreme. We knew about the moon. And Kepler found out about the planets. And nothing is a straight line. There are no straight lines anywhere. Everything is curved. Everything is curved. The flight of the planets, the flight of the moon, the shape of the sun and the planets and the satellites, it's all curved. Why do we use straight lines? We'll be getting into that. But that's a good question to begin our little lecture today. The other reason I wanted you to see this, you'll notice that's pretty close to the half moon, right? It's called the first quarter. And if you're clever, you know which is which. But this could be a photograph of the moon upside down. Well, it's not. You can tell because, well, it's either the first quarter or the third quarter, right? Well, we prefer to say half. That's actually quite controversial even to this day. Why do we say these are quarters when they're not? The moon is never 1/4 illuminated. It's because it looks like a circle. Doesn't it look like a circle? I'm going to explain to you why it looks like a circle to us. It's because of our vision, yes. We cannot see a sphere. But you know I'm not saying enough. Yes, we can. We know that that's a sphere by looking at it. But the ancients had a problem because they didn't know how to think. Don't credit that. That's statistically it's true though. For the longest time, we didn't see the obvious. They teach it to us in school. The ancients were retarded. They weren't as retarded as we were led to believe, but they were ignorant of a lot of things. But the sphericity of the moon, a child can see. And as for the Earth being spherical, anyone can figure that out. Anyone can. So don't believe the flat earthers. Don't believe people who say that we didn't land on the moon. Don't believe people who say that the universe exploded in a ball of fire out of nothing. Don't believe people who say the universe is expanding. Don't believe people who say that black holes are fully understood and they swallow light. Don't believe them. But there's a lot more that you need to know so that you'll know some other things that you definitely do not want to believe that are being taught by PhD professors. And of course, that's going to step on some toes. I am not leading the way on this, children. I am not a vigilante. I'm certainly not poking fun at anybody. But we need to get some answers. We want all the answers. That's what science is for. It's for you and me. Not anymore, it's not. But now that you're tuned in to Anagalactic, I consider myself to be massively different. The other aspect of this photograph is the straight line. Do you see it? You should. It's a perfectly straight line. Well, of course, there's a couple more footnotes, aren't there? It can't be a perfectly straight line, because first of all, it's a spherical surface, and second of all, look at all those craters. Look at those. It's jagged. Yeah, I think you know that there are two answers that are both right. Is that a straight line? Yes and no. It's not a straight line if you want it to not be straight, because it definitely isn't. But is it a straight line? Oh, yes it is. The most perfect straight line that nature, God, the cosmos, or the aliens, or the quantum projector, or we're just fooling ourselves, and there's no such thing as anything that we see. That's all being discussed today. Very important to get back to basics. Is that a straight line? Yes, it is. It's absolutely straight. There is no straighter line than what you're looking at in the whole universe. But isn't that actually a circle? Yes. Yes, it is. That's exactly what it is. It's a circle that exactly divides the moon in half at all times. If you were above the Earth-Moon system looking down, you would never see anything except this. It's always a half. That's called spherical symmetry. And it's one of the most important principles you'll ever take to heart as you learn a new geometry that has never been taught, not by the Greeks, not in any school, anywhere in the world, ever. There has never been a class taught on the face of this earth. I checked. And if you can disprove me, I'll reward you. There has never been spherical geometry anywhere. You know what it's called instead? Spherical trigonometry. You know what trig means? 3 straight lines. But look at that. Look at that. Is that a straight line? I say it is. In fact, there are 2 straight lines in this photograph. One of them is the edge of the moon that looks like a circle. That is a straight line. The entire moon in my geometry is a straight line. And you may think, well, that is the wildest shit I ever heard. Not when you switch to the right number system. And we'll be getting to that. That was the reason for looking at this, looking at this, and looking at this. This man, John Conway. Some men's names, you always say the middle name, like, and John Horton Conway is always called that. I'll call him John, I'll call him John Conway, I'll call him John Horton Conway. He's one of my teachers, and he's the last polymath that will ever be born. I predict that. There won't be any more polymaths. And John was the last. And there have been many men who have been called polymaths. John von Neumann was. No, he wasn't, but John Horton Conway was. And the man before him that we know for sure was a polymath, which is what? A man gifted in many aspects of science. Gifted. You usually only get one of those. A polymath gets several. And John Conway was one of those. And the only one we know before him was 250 years earlier. Ruđer Josip Bošković. Why do I say that? He discovered the atomic shell structure before Bohr did by 150 years. That's pretty good. He did better than that. He did way better than that. He learned directly from Newton and Leibniz, including their calculus, and he figured out the mechanical law of the universe, one law, that explains everything. And if you don't believe that, I don't blame you. But if you're brave, continue to listen. Otherwise, you'll end up listening to this guy. I listen to him. I like him. But he is way into the pudding or the system or the hype, the false excitement. He himself is okay. It's pretty obvious that he's not taken in, but you see, he has 2.8 million subscribers. And so he's gone. Once you have that many people listening to you, there is no way on God's green earth that you're going to be able to stay out of the shit. And look what his title is for this. Just 1 month ago. What if space and time are not real? Well, then there's no universe. This would be my answer. Well, you don't want to end up like that. It's worse. He's doing fine. But people who listen to him, who think that they're actually getting what they want, depends on what you want, but you're getting nothing but entertainment. You may just want, that's why I watch him. He's great. Oh, he tells it like it is. He doesn't lie. I would say not. He's very good. But it's very obvious when he thinks something is dubious. And the reason why he made this was partly to disambiguate the nonsense. There's a lot of it. A lot of it. It doesn't come from the rabble. It doesn't come from trolls. It doesn't come from uneducated people. It comes from the top. Things like space is expanding. Cosmological expansion is equivalent to natural selection. It simply isn't even scientific. It's definitely not true. But in order to combat this plague of just guessing, you have to have a better answer. That's where I come in. Let's check the time here. That's 53 minutes. We're going to have some more. I want to show you. This is what I had been talking about for the past 9 months. More or less bracketing information. Obviously, the Earth and ecology is not astronomy. But the Earth is a planet, and we're not anywhere else. We're here. So I consider Earth to be significant. So where did the Earth come from? In order to understand where the Earth came from, you need to know the most recent geological events that shaped the present Earth. Do you? Well, no you don't. And if you do, you're lying. And I know that for a fact. I could be wrong if you know what I know. But I would bet any amount of money that you don't know what I know. And it's in Wikipedia. Right here. Chicxulub. That is the Genesis flood. Okay, I just think that's really interesting since science proved it. It's science now. It's not a guess. The Earth was hit by megatsunamis. I didn't make up that word. Wikipedia did. Lunar geometry, I just showed that to you. The moon shows phases. That teaches you spherical geometry. It teaches it to children. It's the first and only geometry they ever learn. And that's why you're never taken under the night sky. Your parents won't take you out to look at the night sky. Your educational system will not take you under the night sky. They'll never talk about geometry except the Greek straight lines. I'm going to save you from that. Celestial mechanics. I spent quite a bit of time talking about Kepler, and you could guess Galileo, but not really, because we already know about him. But celestial mechanics, what do you know about it? Well, I just put it in there because you really should know about it, right? Any straight lines in celestial mechanics? None. There are no straight lines in celestial mechanics. Everything curves. That's the point. Anagalactic tours, I still give tours of the universe. I was doing that before I learned a new geometry, and now I have to share it. Recently, I've been talking about the edge of outer space. That's one of the physical infinities. There's another one at the center, was just recently discovered. It's called quantum mechanics, and those are the two physical infinities. So I talk about that in the two mathematical infinities, and ironically enough, our linear number system teaches us the correct geometry. And I'll share that with you again. The fave rave is Albert Einstein's SpaceTime. Astrophysics is governed by SpaceTime. You know what SpaceTime is? It's the linear formulation of geometry. Linear? Yeah, and so, what do you know about SpaceTime? Nothing. And neither do the astrophysicists. And neither do the quantum mechanists. Because space-time, you can't understand it with lines. And I'll prove to you that you can't. You need spheric geometry. I discovered that in 2022 and rigorously proved that it's a consistent geometry with a closed number system that is an extension of linear numbers. That's critical. Subatomic physics. What do you know about subatomic physics? Let me tell you what the subatomic physicists know about subatomic physics. I'll say we here, we discovered the electron, and we discovered the proton. And that's it. Everything else is mathematics. The neutrino is a hoax. The Higgs boson is a lie, and the particle soup with all the pions, muons, and shittons, they're nothing but mathematical formulations for ignorance. And I will prove that to you as well, with the help of Roger Bošković and John Horton Conway, and my new geometry, and the number system that explains the quantum paradox. It also explains supermassive black holes. We're getting there, but in the next lecture, as I've been promising, I'm going to give my fourth lecture on the flight of the photon. Don't forget, I've already uploaded 300 lectures, averaging about 45 to 50 minutes each. This is what we're going to be talking about in the upcoming lectures. This is just bracketing information, the line and circle and sphere. There's the moon terminator. That's a straight line. On Saturn, you can see a straight line at the North Pole because there's a hexagon. I'll show that to you in just a moment in a photograph. Interacting galaxies, that doesn't show a straight line, but I wanted you to know about interacting galaxies because I'm one of the foremost experts, certainly visually. I fell in love with interacting galaxies, and I've studied well over 600 of them. And now I'm looking out. I went tonight to show you just one interacting galaxy photograph. My database of interacting galaxies was destroyed in the campfire. I'm sorry to say that, but it's true. I have hundreds of photos of interacting galaxies, and I have my own rather advanced theory about interacting galaxies, which is quite significant. But to find an example of interacting galaxies, somebody's withholding that information from the internet. I don't know if it's Google or just nobody knows or nobody remembers that there's such a thing. There should be thousands of pictures of these interacting galaxies all over the internet. There are none. So I'm going to show you one. Virtually none. Now, you may have heard of the active galactic nucleus. That's a misnomer. And this term here, dragon, I'm an expert on dragons. If you type that in and try to get a couple of photographs maybe of what I mean, because it's something astrophysical, you'll get pictures of dragons. And in order to get a picture of this is a double radio-lobed active galactic nucleus. It's one of the most amazing things you'll ever see, except for the interacting galaxies and the hexagon on Saturn, and anything else that you find in the sky is well beyond anything you're going to find on Earth. In terms of beauty, to captivate your interest and make you smart and wise and happy, and you're already getting to heaven, so you don't need to worry about getting to heaven anymore. You're going with me, so to speak. All right, that's an hour, though. Thank you for tuning in. Sorry about my hair, but when I am pointing over here to whatever's over there, I can't see my face. And I do that so I can coordinate one screen with the other. But if my hair sticks out, which this is the second time it's happened, look at the last lecture, you'll see it again. I can't correct the hair. And so it just sticks out like... So, thank you for tuning in. I hope you're going to have fun. I certainly am going to have fun. I've been having fun. I wouldn't do this if it weren't fun. But the reason I'm doing it is because I'm a scientist now. And that's what a scientist does. You're taking a vow. Your soul, for me, you don't have to agree with my code. But when I signed up for science, I went all in. And if you make a discovery, it doesn't make any difference how shy you are, how much you love your privacy, which I do. You have to share it. And if you can't be listened to and people are going to scorn you because you sound like a troll, because everyone who does this is a troll. Well, I'm not. But I'll try not to sound like a troll. We're just going to share information. I won't make anything up. I won't do it. I will not do what these guys do. I won't say theories unless I say it's a theory. You can't just say to children that the universe is expanding. If I had the power, I'd have them all shot. You can't ever do that. Not once. You cannot make up something and teach it to children as if it were true about the universe. If you have a theory like your bullshit Big Bang, you're allowed to have it. But the minute that you pretend that it's true, you're executed. That's how I live. But this is supposed to be positive, but don't forget we're on Earth. Nothing is positive on Earth. There's liars, there are thieves, there's brutality, there's pride, there's wickedness, there's just stupidity. There's a system that promotes this. So don't ever blame any individuals. I never do. Except I use some emblematic names. I don't hate Brian Greene or Neil deGrasse Tyson. For the same reason that I don't love Dr. Sabine Hossenfelder. I'm trying to get attention. So I could do whatever I want with Brian Greene and Neil deGrasse Tyson. They're toads. All they do is make money and lie to you. And I'd say that right to their faces. No, I wouldn't. No, I wouldn't. because I look up to them. I really do. But I am addressing a situation, not humans. But yeah, I mean, you got to have examples somewhere, and Brian and Neil just love to make jackasses out of themselves. Well, if that's what you love to do, and you're causing harm, which they are, then you're fair game for someone like me. And for Dr. Sabine Hassenfelder, who takes them all by the ear and just cracks their head against the wall and tells them to sit down. I love Dr. Sabine Hassenfelder. But no, I don't. She doesn't have any answers. I still love her, though. You see, I can't help it. Well, it's the same thing as hating Neil deGrasse Tyson and Brian Greene. I don't hate them. I hope you're having fun. Not. I just want you to know a little bit about what I do. We're going to be studying spheric geometry in context of the universe so that we can understand the universe. Would you like to understand the universe? In the next lecture, I'm going to explain to you why space seems to be infinite and why light can travel from distant stars and hit your eye. That's a pretty good aim for a photon, isn't it? Yeah, you start thinking about that. We'll be right back. This is Anagalactic broadcasting to you on the 27th of March. Holy smokes, hope you paid your rent. We're heading into spring. We're in spring now. We have been for 7 days. And we're heading from the vernal equinox to the summer solstice, which is when I began last year teaching you the secrets of the universe. Pretentious, precocious, pompous? Oh, yeah, but it's true. It better be true, or I'm going to hell. Right?